All right, let's dive into something that is a genuine game changer in the world of medical AI. We're going to be talking about a new approach that could make medical diagnoses not just a little better, but way more accurate, faster, and, get this, a whole lot cheaper. It sounds too good to be true, so let's get right into it.
So this is the big question, right? For as long as I can remember, the thinking has always been, okay, you can have better or you can have cheaper, but you can't have both. It's a trade-off. Well, what if that's not true anymore? What if a new innovation just completely rewrites that rule? That's exactly what we're looking at today.
You know, the potential for AI in medicine it's just incredible. It can look at medical scans and see things, find patterns that the human eye might just glance over. It helps doctors diagnose really complex diseases with a level of precision that's just mind-blowing. But to really unlock all that power, we need to bring different kinds of information together. And that's where this idea of multimodal fusion comes into play. Just think of it like putting together a puzzle. An MRI gives you one piece of the puzzle, a CT scan gives you another. By fusing them together, the AI can see a much richer, way more complete picture of what's going on, and that leads to a much, much better diagnosis. Okay, but here's the catch. Here's the dilemma. The most powerful AI models we have right now, they're basically supercars. Yeah, they're absolute beasts, unbelievably powerful, but they guzzle computing power like it's nobody's business, and they are incredibly expensive to run. That means most hospitals, most clinics around the world, they're just completely priced out. So this whole supercar problem really boils down to two main villains in our story. Two things that are stopping this amazing tech from being everywhere. Let's call them leaky pipes and power hogs. Let's break down exactly what that means. The problem really starts at the blueprint, the basic design of the AI. See, the old way, what's called a cascaded approach, handles information one step at a time. It's literally like that game of telephone you played as a kid. The message gets passed along, and with each step, details get a little fuzzy, a little lost. The new way, though, processes everything at once, in parallel. It's like having two top experts looking at the same problem at the exact same time, sharing what they see instantly. So that old cascaded method, that game of telephone, has two huge flaws. First, you get information loss. Those are our leaky pipes. Really crucial details for a diagnosis can just vanish. Second, it's a power hog. It's built on these super complex, resource-heavy designs that make it slow, expensive, and really hard to scale up. And this is where our hero finally enters the story. To solve this whole problem of leaky pipes and power hogs, researchers came up with a totally new design, a new architecture, called DrifaNet++. And it's built on this smarter, parallel approach that just completely changes the game. This quote from the research paper itself really just nails it. DrifaNet++ is a parallel cross-fusion architecture. That's the technical term for our two experts approach. And the goal is crystal clear. Get the absolute best performance possible with the lowest cost imaginable. So how does it do it? Well, DrifaNet++ has this really clever two-part strategy. First, it processes different kinds of data at the exact same time. So it's looking at the shape of a potential tumor, that spatial info, and its texture, the frequency info, simultaneously. No more game of telephone. And second, it was just built from the ground up to be efficient, with lightweight parts. It's not about brute force, it's all about smart, elegant engineering. Okay, so the theory is fantastic. It's brilliant. But does it actually work in the real world? Well, the researchers put DrifaNet++ to the test. And I mean really tested it, on 11 different medical imaging datasets. And the results? Well, they were nothing short of incredible. It was a stunning victory. I mean, look at this. Compared to the other top models, DrifaNet++ boosted the diagnostic performance by 2.6%. Now, that might not sound like a huge number, but in medicine, every single percentage point can make a world of difference. But here's the real jaw-dropper. It did all of that while cutting the computational costs by over 80%. It's better, and it's massively cheaper. Let's just put this into perspective for a second. The old version of this model was already better than its competitor, but it was also twice as expensive to run. Now, look at the brand new DrifaNet++. It's the most accurate one on the list by a good margin, and it's by far the leanest and cheapest to run. It's really like having a car that's faster than a Ferrari, but somehow gets the gas mileage of a hybrid. It's the best of both worlds. So what's the big picture here? Why are we so excited about a more efficient AI model? This is where we go beyond the tech specs and the code. Because this isn't just a cool engineering achievement. This is about bringing incredibly powerful technology out of the lab and into the real world for everyone. It really all boils down to three huge takeaways. 1. More accurate diagnoses. That means better decisions and better outcomes for patients. Simple as that. 2. Because it's so efficient, you don't need a supercomputer to run it. That radically slashes the cost of the hardware you need. And 3, and this is maybe the most important part, this makes it accessible anywhere. A small clinic in a rural town, a remote hospital, you name it. And that is the real magic here. For way too long, the best medical technology has been locked up in just a handful of wealthy, well-funded hospitals. And innovation like this has the potential to completely democratize that power. It makes advanced AI a practical, affordable tool for the doctors and patients who have always needed it the most. So, I'll leave you with this final thought. What happens to global healthcare when a doctor's expertise can be supercharged by a world-class AI that isn't locked away in some massive data center, but can just run on a normal laptop anywhere in the world, for anyone? It's a really powerful question to think about, and thanks to work like this, we might actually be on the verge of finding out the answer. Thanks for joining us.